So yesterday we were working with this simulation and I wanted to talk a little bit about the questions that were part of part 3, that second slide of questions, because they help illustrate some important concepts. One, how amazing and rare the type of total solar eclipse that we have on Earth is. And also it helps explain why we have more lunar eclipses. They happen more frequently than solar eclipses do. So one of the things I want to show you is here in the lunar eclipse position. If I change the tilt, you can see the moon is going up and down, and some of that time it's in the shadow of the Earth and some of the time it isn't. And then the next questions asked you to change the size and distance between the Earth and the moon. And then it asks you, do we still have a lunar eclipse? And your answer is going to be yes, but your explanation needs to talk about what's changing, but what's staying the same. So the size of the moon is changing. It looks bigger or smaller, and the size of the Earth's shadow is changing. But despite those changes, the moon is still completely covered, so you still get a total lunar eclipse. On the other side, when we're looking at solar eclipses, the total solar eclipse on Earth is really unique because the sun and the Earth and the moon, even though they are very different sizes, they are also very different distances from Earth. And so they end up looking almost identical sizes in the sky. And because of this, we get total solar eclipses that show that ring of energy and light that emanate from our sun called the corona. If the moon is closer to Earth, you get full strength bright sunlight showing around on the outside. You do not get a total eclipse. If the moon is bigger, it starts to block that corona and you don't get to see that ring or that glow around the Earth. The same thing with the size. If the moon were larger, it would completely block out the sun. If it were smaller, you would still have a lot of sunlight showing around the moon. So although you still get an eclipse of the sun, if the distance or size of the moon changes, you do not get a total solar eclipse the way that we do now. You see either what we call an annular eclipse, which is when you can see the sun around the outside, or you completely block that corona and it looks a lot different. So yes, an eclipse still occurs, but make sure you emphasize those differences that occur when the sun and moon are different sizes and distances. So another thing I wanted to point out to you, I said this would show you why lunar eclipses are more common. And if you look about where we are able to completely block and get a total eclipse of the sun, our alignment is very particular. Just a tiny bit of change and we start seeing that sun again and you're not going to get a total eclipse. However, on the other side, for the moon, you have a lot more opportunity for the moon to be a little high or a little low and still be completely blocked. That's because the Earth's shadow is so much larger, so that alignment doesn't have to be as perfect. The alignment of the moon has to be much less precise, and we can still get a total lunar eclipse. So that's why we see total lunar eclipses more often. The last thing I want you to look at is slide 21 in your notebook. I'm going to ask you to turn this completed slide in when you are finished with it. So I want to talk to you about it because this being able to explain these two models will show a good understanding of how the system works. So I'm going to start with seasons because we've talked about seasons before. The Earth is tilted, and that tilt causes the direct rays of the sun to fall above or below the equator at different times of year, and that's what gives us seasons. But twice a year, the alignment is perfect so that the pole isn't tilted towards or away from the sun. It's perfectly crossways from the sun. And on those 2 days, the sun's light will hit directly on the equator. We call those days the equinox. They mark the start of fall and spring. And they're when the sunlight hours are equal because it's hitting exactly on the equator. Although the Earth is tilted, we still get days with perfect alignment. The same thing happens with the moon. Even though the moon's orbit is tilted, twice a year you get a position where the alignment is perfect for the sun to hit directly on that orbit path. If the moon happens to be in position during that orbit path to make an eclipse, then that eclipse will occur even though the orbit is tilted. So think of it like a clock with all the gears moving around inside. As those gears are moving around twice a day at 12, noon and midnight, everything aligns perfectly. Bong, 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 bong. All the bells and chimes can ring. But all the other positions as it's moving around are good positions, doing what they're supposed to do. But only twice a day do you lock into that hands straight up and down midnight position where then all the bells and chimes happen. So just like twice a year, you get perfect alignment for the seasons. Twice a day, you get perfect alignment at midnight and noon for your clock. Twice a year, you're going to get perfect alignment here with our moon orbit. And if the moon is just right, then you might get an eclipse. Answer those questions at the bottom using that information. Download this slide, doing a file download, and then choose JPEG, and then upload that on GoFormative to this assignment.